Well, let's continue the 2013 test with some calculator questions now. The graph of the function f shown above consists of two line segments and a semicircle. Let g be defined by g of x equals the integral from 0 to x of f of t, the area under the curve. What is the value of g of 5? So g of 5 would be equal to the area from 0 to 5 underneath this curve. So we've got a triangle and we've got a semicircle. What's the area of our triangle? 1 times 3 divided by 2 plus, looks like we've got a radius of 2 pi r squared semicircle. So 1.5 plus 2 pi. Get it? This 77 is one of those questions we talked about throughout the year. The volume of a sphere is decreasing at a constant rate of 3 cubic centimeters per second. So we've got a rate. At the instant when the radius of the sphere is decreasing at a rate of 0.25 centimeters per second, what is the radius of the sphere? And then they will give us, for a problem like this, a formula we might need. The volume of a sphere with a radius r is 4/3 pi r cubed. So the volume of a sphere is decreasing at a constant 3. At the instant when the radius of the sphere is decreasing at a rate of 0.25, what is the radius of the sphere? So let's go ahead and look at our equation. V equals 4/3 pi r cubed. And if we derive that, we end up with dv dt equals 4/3 times pi times 3r squared. Remember, that's just one of our constants. So the 3 is going to go with the 4. dv dt equals, and then what did we forget here? dr dt, there it is, equals 4 pi r squared dr dt. And I think we're pretty close now. The volume of the sphere is decreasing at 3, so 3 equals 4 pi, and r is what we want to know, and dr dt is 0.25. So let's go ahead and solve. Divided by 0.25, or 0.25 times 4, let's just call that 1. Divide by pi, 3 over pi equals r squared. Take our square root, and we get that 0.977. All right, number 78. F and g are continuous functions such that the area of f from 0 to 10, let's just kind of, I don't know, some kind of a quick graph here, 0 to 10 is 21. And I like when they throw these little 1/2s in there. The area of g from 0 to 10, 1/2 of it is 8. That 1/2 can go here, which can actually get multiplied over as a 2. So I'm going to call that 16. And the area from 3 to 10 of f of x minus g of x is 2. So the difference between them is 2. What is the value from 0 to 3 of the difference between them? Well, the difference between them is 5. And if the difference between them here is 2, then the difference between them here has to be 3. All right, we've got a interpretation graph in 79. The figure above shows the graph of f prime, the derivative of the function of f. If f of 0 is 0, which of the following could be the graph of f? Well, the good news is all of these start at 0, 0, so we can't eliminate anything. That's convenient. Which of the following could be the graph of f? So let's talk about what derivatives do. If derivatives are positive, the functions are increasing. So this function has to be increasing from 1 to 2, and 3 to 4. So let's look. Increasing from 1 to 2, nope, it's decreasing. Increasing from 1 to 2, you bet. Increasing from 1 to 2, nope. Increasing from 1 to 2, nope. Increasing from 1 to 2, yes. Increasing from 3 to 4, nope. Increasing from 3 to 4, yep. Increasing from 3 to 4, yep. So I think we're still looking at these two. Then the last thing we have to look at is how much of is their decrease. So we get into this discussion in like physics about this area and this area. This area is much smaller than this area here. So our decrease could not be this extreme. This would require a lot of negative area in order to decrease this much. So the only possible answer is going to be C. And that's talking about displacement. All right, and let's finish with 84. The graph of the function f is shown above. Which of the following statements is true? F of a is 2. I would say f of a is 1. F is continuous at x equals a. Nope, we've got a hole. The limit as x goes to a of f of x is 1. The left is going this way, the right is going this way. They are definitely not going to 1. The limit as x goes to a of f of x is 2. That is definitely the true one. And the limit does not exist. The limit does exist from the left and the right. It is not continuous. And the limit is 2. Way to math it up.